Hey, hello there. So in this video we are going to write few more codes on operators. Okay, so let's quickly get started. So the first let me quickly read the problem statements that we are going to see in this video. Okay, so the first problem statement is find out whether the given number is even or odd without using modulus operator. Then in the next statement we have to do a simple mathematical calculation. Okay, so there is one simple expression given, so we just have to calculate that. So we have to find out its value or its answer. Okay, and in the third problem statement we have to find out, or we have to write a C++ code to get nth bit of a given number. Okay, so so let's quickly get started with the first problem statement, and as and when I will be discussing any problem statement we are going to see it in much more detail. Okay, so let's get started with the first one. So let me quickly move to the Visual Studio Code and then let's start writing a code. Okay, so now I'm on the VS Code. Let's quickly get started. Now this question one is very interesting, and actually it's been asked multiple times during the placement interviews. That's why I focus very carefully on this question. Now the question is, we have to check whether a given number is even or odd without using modulus operator. Okay, now let me just give you a basic idea about how we can actually solve this problem, how we can solve it without using a modulus operator. In one of the previous video we have seen how we can find whether given number is even or odd with the help of modulus operator. We have seen this, right? With the help of modulus operator, how we can find whether given number is even or odd. But in this question what we have to do is we have to check whether given number is even or odd without using modulus operators. Okay, now focus very carefully. Let's say my number is 2, okay, which is an even number. So let's take two examples. First number that I'm going to take is going to be 2 in decimal, which is an even number, and let's take one more number which is, let's say, 3, which is an odd number. Okay, let's quickly convert them into 4-bit binary. So 2 is going to be 0010, correct, and 3 is going to be 0011. This is the binary conversion of 2 and 3. Now let's see how modulus operator logic was working. So what we used to do is we used to take, let's say, number modulus 2. So whenever number is even, modulus operator used to give us 0 as the output, and whenever number used to be odd number, modulus operator used to give us 1 as the output. So we used to use this condition as a checking condition, or the condition for checking whether a given number is even or odd. So this used to be our condition. So we used to check if number mod 2, if it is equal to 0, if the condition evaluates to true, that means a number is an even number. If condition evaluates to false, that means a number is odd number. So this is something that we used to do. Now how we can solve the same problem without modulus operator? This is interesting, right? So I have one very interesting operator with the help of which we can find whether a given number is even or odd. Okay, how we can do it? So the operator, let me quickly reveal you the operator. So the operator is bitwise AND operator. This operator is a savior for us. Okay, so this is bitwise AND operator. How bitwise AND operator is going to help us? So let me show you a quick demonstration. So focus very carefully. You take any even number. Okay, take any even number. Let me take one more number, let's say 4, okay, in decimal. Let me quickly convert it into binary. 4 is nothing but 0100, correct? So this is 4. Let's take 6 in decimal. So 6 in binary is nothing but 0110. This is 6 in binary. You take any even number, you can find that the rightmost bit or the least significant bit of the even number is always 0. You can check. See, every time you see any even number, its least significant bit is always going to be 0. Because if you see numbers carefully, see this position, the position value of this position is 2 raised to 0. Positional value of this position is 2 raised to 1, and so on, right? So if you see, this 2 raised to 0 is nothing but 1. 2 raised to 1 is nothing but 2. Over here we have, let's say, 2 raised to 2. So 2 raised to 2 is nothing but 4. You add any even number, you add any number of even numbers, the addition is always going to be an even number, correct? And if you see very carefully in this number, all the positions after this position or leaving this position, all the positions on the left hand side, they have even positional value. You can see 2 raised to 1 is 2, 2 raised to 2 is 4, 2 raised to 3 is 8, 2 raised to 4 is 16, 2 raised to 5 is 32, and so on. all the positions on the left hand side except the least significant bit. See, this bit is called as least significant bit, okay, LSB. Except the least significant bit, all the bits have even positional value, and you add any number of even numbers, they will give you even output, even result. So we can say that this least significant bit is a deciding bit. It decides whether your number is even or odd. We can say that if our LSB is 0, if the least significant bit is 0, then we can say that a number is an even number, okay. And if your least significant bit is 1, we can say that number is an odd number, okay. Now, how we can use this logic to implement our code? See, what we are going to do is, we can take bitwise AND with 1, okay. So let's see that. See, I'll take 2 over here, so I'll write 0 0 1 0 over here, right? This is my 2. I will take bitwise AND with 1. So what is 1 in binary? 1 in binary is nothing but 0 0 0 1. Now we know that how bitwise AND operator works. So basically we have to take AND operation on all individual bits. So 0 and 0 will be 0, 0 and 0 will be 0, 1 and 0 will be 0, 0 and 1 will be 0, correct? So observe very carefully, in case of even number, after doing bitwise AND operation, after performing bitwise AND operation with 1, the result that you are going to get is going to be 0. It's going to be 0. Why it's going to be 0? Because see, when you are taking bitwise AND with 1, all the bits on the left hand side are 0, only one bit, that is the least significant bit, is 1. And in case of even number, the least significant bit is compulsory going to be 0, right? So all these bits in the even number, all the bits on the left hand side of LSB, they are going to become 0 after taking bitwise AND with 1, right? Because in the 1 also all left bits are 0. And this bit in the even number is going to be 0, whereas this bit in 1 is going to be 1, and 1 and 0 is going to be 0. That's why in case of even number you are going to get 0 as the result. Now what happens in case of odd number? Just focus over here. So let's take example of 3. So 3 is nothing but 0 0 1 1, correct? If you take AND, bitwise AND with 0 0 0 1, okay, what happens? 0 and 0 is 0, 0 and 0 is 0, 1 and 0 is 0, and 1 and 1 is 1. So in this case you are getting output as 1. You try with any odd number, any even number. In case of odd number you will always get output as 1. In case of even number you will always get output as 0. And that's our condition. That's the condition that we can use. So what we can say is, whenever you have a number, whenever you take bitwise AND with that number, if the result is 1, we can say that number is odd. And whenever you take AND with 1 and whenever you are getting 0 as the result, we can say that number is even. That's the logic. Let's quickly move to the VS Code and let's implement this logic in VS Code. Okay, so what we'll do is, we'll first create one variable, integer no. Let's accept this no input from the user. So we'll write cin no. So user will input some value. Okay. Now what is our condition? See, our condition is, if no and 1, if this is equal to 0, then this basically means that it's a even number, correct? And if no and 1, if it is equal to 1, then it means that it's an odd number. So these are our conditions. So basically we can use any one condition and we can write a conditional operator. So what I'll do is, I'll write no and 1. If it is equal to 0, so I'll take this condition. So if this is equal to 0, question mark. So if this is equal to 0, then our number is going to be even number. Otherwise our number is going to be odd number. Okay. And let's print it in cout statement. So I'll write cout, the given number is focus on how I'm writing the code. So what I've done is, in cout I have added one string. Okay, so I have written one string followed by this expression. So whatever I'll get as the, see, I'm again making the same mistake. See, this needs to be in double quotes. Okay, so first this string will be printed, and then whatever is the result of this expression, that result will be printed. So either it's going to be even or it's going to be odd. Let's quickly execute this code and let's see whether it is working or not. So I'll write g++ followed by code1.cpp, which is the name of my file. So the code has now got compiled. Let's execute this code. Now we have executed the code. You can see the prompt is waiting for our input. So let's enter an even number. You can see we are getting odd as the output. Okay, why we are getting odd as the output? Why not even? See, ideally, as per our explanation, we should get even as the output, right? But we are getting odd as the output. I'll tell you the reason. So in this expression over here, we have two operators, and equal to equal to. Equal to operator has more precedence as compared to and operator, and that is something which is happening over here. So what we need to do is, we first need to execute this part and then we need to check it with 0. We need to check equality with 0. That's why what I'll do is I'll put this thing in the bracket, because bracket has the maximum precedence. Okay, so what was happening? Equal to was having more precedence as compared to bitwise and operator, and that's why this thing 1 equal to 0, this thing was getting executed first. So that's why we were getting some unexpected output. So now it should work properly. So we'll compile it again and now we will execute it. Let's enter 10. You can see we are getting even output now. And let's say if I enter 11 now, you can see we are getting odd as the output. So this is the simple code to check whether a given number is even or odd with the help of bitwise and conditional operator. Okay, so in the second problem statement, what we have to do is we have to do this simple calculation. So we have some number, okay, and we have to perform some operation like division and then multiplication, and there are some powers as well. Okay, so we have to do this calculation. We have to divide 10,48,576 with 2 raised to 19. Okay, and then whatever answer we get, because this is written in bracket. Okay, so we all know that the bracket will have maximum precedence. Okay, and then whatever answer we get, we have to multiply it by 2 raised to 7, and then we have to take the mod with 4 of the answer. Okay, so this is something which we have to do. So let's quickly see how we can perform this calculation. So before directly jumping onto the Visual Studio Code, let me show you how we can perform this operation, or what exactly the statements we need to write on a whiteboard. Okay, so let's quickly see what steps we need to write on the whiteboard. So I have written our expression on the whiteboard. You can see the expression. Okay, now let's try to understand how we can write the same expression programmatically. Okay, in a programmatic way, because see, we cannot write 2 raised to 19 in program, right? Because it's not like a word file so that we can type 2 raised to 19 where 19 is superscript. It doesn't work like that. So basically we have to perform this arithmetic expression, or we have to solve this arithmetic expression. So we have to convert this mathematical representation into a programmatic representation. Okay, so let's quickly see how we can do that. See, we all know that for division, we have division operator in C++. Okay, so division can be done with division operator, and it is written like this only in C++. Okay, so this is the division operator in C++. Similarly, for multiplication, we have multiplication operator in C++. For modulus, we have modulus operator in C++. What about this power operation? Okay, we have to write 2 raised to 19. Then we have to calculate 2 raised to 7. So do we have any inbuilt operator for taking powers? Just try to remember, have we learned about any such operator which is helpful for taking power of some number? Do we have any such operator? The answer is no. We don't have any inbuilt operator for taking powers of a number. Okay, so we cannot perform operation like this, that is 2 raised to 19, with the help of some inbuilt operator. See, many people get confused over here. Many people think that if they write something like this, okay, 2 followed by this caret symbol followed by 19, so they think that they will get power of 2 to the power 19. Okay, so they feel that this expression is equivalent to this expression. Okay, but it's not true. We all know that this caret symbol in C++ denotes a operator which we basically call as bitwise XOR operator. Okay, so this is not operator for taking powers, it is a bitwise XOR operator, right? So we don't have any inbuilt operator in C++ for taking powers. Okay, and that's the reason we have to do some tricks for solving this example. Okay, so there are two ways by which we can take powers. This is very important, so listen to it very carefully. There are two ways by which you can calculate power of any number. Okay, so the first way so let me write it over here. The first way is using a standard library that is called as CMath library. Okay, so there is a standard library called as CMath, and this library provides a function, and name of that function is POW. Okay, so you can use this POW function to take powers. Okay, now this function actually takes two input. The first input is the base, and second input is exponent. Okay, so let's say you want to calculate 2 raised to 19, then what you can do is you can call POW power function, and then you can pass 2 comma 19 as the arguments. Now see, we have a separate module on functions. Okay, so I'm going to explain you what is function, how it works, how we can create our own function, then what are the library function, how we can call a function, all that stuff in a separate module. It's a big module. Okay, so we are going to discuss that module separately. So once you provide this two input to this function will return us the answer of 2 raised to 19. Okay, or 2 base raised to exponent, whatever base and exponent you are providing. Okay, it's that easy, right? So we can make use of this inbuilt function, that is POW. All right, and the another method which we can use is using shift operator. Okay, so we can also use shift operators to solve this example. I'm going to explain you how we can make use of the shift operators to solve this example. Okay, so let's quickly go to the Visual Studio Code and let's quickly see how we can solve this expression with the help of CMath library and POW function. Okay, so let's first solve that. Now let's quickly write it in the C++ way. Okay, so as I said, see, other things are very easy. I mean, division and all that, we will write it in the same way. The only trick here is just about taking powers. Okay, so let me just write our answer. So let me store the answer in, let's say, integer variable. So I'll write int ans answer, okay, is equal to, what is going to be the answer? So it is nothing but 1048 then 576 divided by 2 raised to 19. So how we can write 2 raised to 19 in C++ way? So we have to write power function and we have to pass two arguments to it, 2 and then 19. Okay, now to use this power function you have to include a header file, and the name of the header file is CMath. Okay, and okay, so you are dividing it by 2 raised to 19. So we have to put this in brackets. So let me just encapsulate it in bracket, and then I have to multiply this thing with 2 raised to 7. Okay, so how can I write 2 raised to 7? So I can again write power 2 comma 7, and then finally we have to divide this complete thing, or we have to get modulus of the complete thing with 4. So I'll write modulo 4. So finally we are going to get our answer in ANS variable, and we'll just print whatever is present in this ANS variable. So I'll write cout ANS followed by ENDN. Okay, hope it will work properly. Okay, right now the editor is giving us some error. Let's see, let's compile our code and let's see whether the compiler is also giving some error. Okay, so let me clear my terminal. Let's write g++ followed by code2.cpp. Okay, so even the compiler is giving an error to us. So let's see what the error is exactly saying. So it is saying that error invalid operands of type something like promote int double double type aka double and into binary. Okay, let's try to figure out why we are getting this error. So let me do one thing. Let me just do some modifications over here. I'll explain what I'm doing. Okay, so let me just write in front of it int, similarly over here as well. Okay, now let me save it. Now let me check. Okay, So now the code is getting compiled. Okay, let me first show you the execution and then I will explain why I did that change and why now the program is working properly. Okay, so let me quickly execute this code. So let me write a.exe. So you can see that right now we are getting answer as 0. Okay, so this is the answer. This is the simple code that we had to do. Now what I did, okay, what I basically changed. So basically the power is a function. Okay, now in C++, just remember this thing for now. Even if you don't get it correctly or don't get it 100%, that's fine. Okay, but right now just try to remember this thing. See, in C++, whenever you write a function, then function can take few arguments and function can return some value. Okay, so it's like this. A machine can take an input and it can return some value. There can be some machines which don't take any input and which don't give us any value in return, but they do just some task. Okay, so this power function, what it is doing, it is taking two inputs and then it is giving us some return value. Okay, and that return value is nothing but the answer of the power. Okay, so whenever we are writing 2 raised to 19, so in that case we are calling the power function, we are passing 2 and 19 as the argument, and what this power function is going to return us, it is going to return us the answer of 2 raised to 19. Now whenever a function returns any answer, the function will have some return type. Okay, so what is return type of the function? See, I'm going to tell you all these things in the model call as function, but right now just for your understanding I'm telling you because we just had this scenario, that's why I'm telling you. Okay, so return type of a function basically means what value the function is going to return, and that value is of which data type. Okay, so whatever value the function is going to return, what is the data type of that value, that is the return type of the function. So by default this power function returns a value of double data type. Okay, so double is the return type of the power function. Okay, but all our expression is actually in integers. Okay, you can see we have the first number which is 10,48,576, it is integer. Then we are taking modulus by 4. So all the things are happening in integer. That's why the compiler was throwing an error that if you are doing power and then power was executing in double, in terms of double, and then if you are doing int and double, then it becomes a mixed expression. Okay, so the final answer of this part will become a double value. Then the answer of this part will also become a double value. So when you multiply double and double, then the answer is again double. Okay, and we all know the modulus operator doesn't really work on double or float value. It only works on integers, and that's the reason the compiler was giving an error. So now what I'm doing is I'm telling the compiler I want the answer of this power function in integer data type. Okay, so I want the return type of the power function as integer. So that's why I'm writing int in bracket in front of power function, POW function. Okay, so this is the small change that I did. Again, I am going to explain all these things to you when we are going to discuss a separate model call as function. Right now, even if you don't understand what I just explained to you, don't worry about it. We are going to discuss all these things in a separate model, that is functions. Okay, so let's quickly move ahead and let's see how we can achieve or how we can write the same program with the help of shift operator. Okay, now how we can achieve the same thing with the help of shift operators. See, we all know we have two shift operators in C++, bitwise shift operator. One is left shift and another one is right shift operator. Okay, so we all know the very important property of the left shift operator. Whenever we use the left shift operator, whenever we left shift by 1, it is equivalent to multiplication by 2. Whenever we left shift by 2, it is equivalent to multiplication by 4. Whenever we left shift by, I'll say 3, it is equivalent to multiplication by 8. This is something which we have discussed while learning operators. Okay, so let me just quickly note it down on the whiteboard. See, what I'm saying is if you are doing left shift, okay, let's say by 1, then it is equivalent to multiplication by 2. Okay, if you are doing left shift by 2, then it is equivalent to multiplication by 4. If you are doing left shift by 3, it is equivalent to multiplication by 8. Okay, now what if I'll say this 2 is basically 2 raised to 1, this 4 is basically 2 raised to 2, this 8 is basically 2 raised to 3. Okay, so if you do left shift by 19, okay, So what will be, or so in that case it is going to be multiplication by 2 raised to 19, right? See, in case of left shift by 3, it is equivalent to multiplication by 2 raised to 3. Okay, if you do left shift by 19, it is going to be equivalent to multiplication by 2 raised to 19. Now this left shift operator takes two operands. It is a binary operator, so it needs two operands. First operand is the actual value which we want to left shift. Okay, so let's say if this value is n, so when you do n left shift 1, then basically this is n into 2. Okay, if you do n left shift 2, then it is basically n into 4, because as I said, if you do left shift by 2, it is equivalent to multiplication by 4. So when you write n left shift by 2, that basically means n into 4, okay, or n into 2 raised to 2. So based on this fact, if I write something like this, just observe it very carefully. If I write 1 left shift by 19, okay, 1 left shift by 19, then this is going to be equivalent of 1 into 2 raised to 19. Okay, and 1 into 2 raised to 19 is nothing but 2 raised to 19. So in this way we can get answer of 2 raised to 19. Similarly, how we can get answer of 2 raised to 7? So 2 raised to 7 is nothing but 1 left shift by 7. So if you do 1 left shift by 7, that basically means 2 raised to 7. So using this thing, we can modify our program and we can write the same program in a different way. Okay, so let me just quickly go back to the Visual Studio Code and let's see it in action. So what we can do, instead of using this power function and all this stuff, what we can simply do is we can write 1, let me write it in brackets, 1 left shift by 19. Similarly, here as well we can write 1 left shift by 7. That's it. Okay, that easy it is. And let's quickly compile and execute this code. Let's see what we get as the output. See, we are again getting 0. Okay, so these are the two ways of writing the same program. So I hope now you understand how we can write a simple expression in C++. Okay, and I hope now you understand that how we can get the powers of any base and exponent. Okay, so whenever we want to get power, then we can use power function, which basically returns double. Okay, and then you can also make use of left shift operator in case if you want to take power of 2 raised to something. Okay, cool. So I think we are good on problem statement number 2. So let's quickly move to the problem statement number 3 and let's see what we have in problem statement 3. Okay, so let me just quickly take you to the statement 3. So in statement 3, we have to write a simple C++ program to get nth bit of a number. Okay, so let's say we have a number. Okay, and it is going to be let's say it is an integer number. So the integer number, we know that it takes 4 bytes of memory. Okay, so 4 bytes basically means 32 bit. Okay, now if someone asks you what is the 8th bit of the number currently, what is there in 8th bit of a number, and I want to know that what is the value in the 8th bit of a number. Okay, so how can we do that? Okay, so this is something which we have to do in this problem statement. Okay, so let's quickly go back to the Visual Studio Code. Meanwhile, just pause the video and just try to think how you can get nth bit of a number. Okay, so let's say we have 32 bits. Okay, so so let me just draw it over here. Let's say, let me draw a few bits over here. Okay, let me give it some positions. Okay, so this is my 0th position, this is my 1st position, this is my 2nd position. Let's say this is my 31st position, because the total number of bits are 32. Okay, so if I start the position with 0, then the last position is going to be 31. Then this is my 30th position, this is 29th, 28th and 27th. Okay, now if someone asks you, I want the 2nd bit of a number, what is the value of 2nd bit of a number? Okay, so let's put some values in it. So let's say we have values like this: 0, then 1, then 0, then 1, then 1, then 0, then 1, 1. Okay, let's say these are the values. So if someone asks you what is the value in 2nd bit of a number, then we want answer as 0. See, when I say 2nd bit of a number, that means the position is 2. Okay, actually it's a 3rd bit. Okay, so if we count from here, then it's a 3rd bit. So when I'm saying 2nd bit, that means the position. Okay, because the position is starting from 0. If someone asks you what is the value of 31st position, then it is going to be 1. Let's say someone wants second bit of a number, then let's see how we can calculate or how we can find out the second bit of a number. Okay, so there can be multiple approaches. Right now I'm thinking of a simple approach. What we can do, we can make use of a right shift operator. Okay, so if someone asks you this what is second bit, what we can do is just see over here and just try to answer my questions. Okay, so if I do right shift by let's say I want second bit, right? So if I do right shift by 2, okay, then what will happen? See, this bit will transfer 2 bits to the right. Okay, so this bit will basically come over here. Whatever is present in this bit, it will come at 0th position. Okay, so in this case this bit is 0, so basically this position will be filled with 0. Okay, similarly, let's say if someone asks you about what is 31st bit, so in that case also what we can do is we can do right shift by 31. When we'll do right shift by 31, what will happen? This bit will come to this position. We all know how this right shift operator works. Okay, so in case of right shift, the bit will basically shift to one position to the right. Okay, so when we will do right shift by 31, then this bit, which is this bit, will shift 31 positions to the right. And if it shifts 31 positions to the right, then obviously it will come over here. So in this case, this bit will become 1. Okay, so the main idea behind solving this problem is we have to shift the bit, whatever bit we have to find, we have to shift it to the position 0. Okay, now once this bit come to the position 0, what we can simply do is we can take its AND with 1. Okay, so when we take its AND with 1, so let me write 1 over here. So 1 is 0 0 followed by 1 here and all zeros. Okay, so when we take bitwise AND with 1, what will happen? See, all these left side bits are 0, so this is going to be 0 0 0, multiple zeros, and finally only this bit is 1. So if this bit is also 1, then it is going to give 1 as the output. If this bit is 0, then it is going to give 0 as the output, because we know that 1 and 1 is 1. Okay, 1 and 0 is 0. So if both the bits are 1, and obviously this bit is 1 only, so if this bit is 1, then the answer that we are going to get is 1. If this bit is 0, then the answer that we are going to get is 0. Okay, so basically whatever bit is present over here, we are getting it as the output. Okay, so in this way we can basically find the end bit of a number. Okay, so let's quickly go to the Visual Studio Code and let's see it in the code. Okay, see, let's accept one number from the user. Okay, so let me write int number. Let's accept it from a user. So let me write cout, enter a number. Okay, then the user will enter a number. Then let's take it while using scene. Okay, so I'll write scene no. Okay, so now we have the number, actual number. Now we also want to know which bit the user is interested to know. Okay, so I'll write int bit position. So I'll write cout, enter bit position. I'll write scene bit. Okay, so now we have number as well as bit position. Now we have to give output to the user as what is bit present at that bit position. So what is the output? So the output is nothing but cout number right shift by bit position. Okay, and then we have to take its AND with 1. Okay, let me write this thing in bracket because we want to execute this thing first, and then whatever answer this thing gives, we have to take its AND with 1. Okay, and then finally I'll write endl. Cool, so I think it looks good, but there is some error that is coming up. So okay, so this error is because of the parenthesis. See, whenever we are writing cout, we have to remember whenever we are writing any expression, we have to actually enclose the complete expression in parentheses, because sometimes the compiler, not sometimes, most of the times the compiler gets confused due to the expression. Okay, so we have to enclose the complete expression in the parentheses. Okay, it should be here. Yeah, that's it. So now let's quickly compile this code. So I'll write clear and then let's compile the code. It is code3.cpp, and then let's quickly execute it. So let's enter a number. Let's enter 2. Okay, so 2 is the number that I am entering, and let's find out value of a bit at the first position. So in case of 2, what is going to be value at 0th position? It is going to be 0. Value at first position is going to be 1. Okay, so if I enter bit position as 1, then the output that we should get is 1, and we are getting it correctly. Let's enter number again 2, and let's enter the bit position as, let's say, 0. Okay, so in this case the answer should be 0 and we are getting 0. So our code is working properly. Okay, so yeah, that's it for the third problem statement. So I hope you got all the 3 problem statements. I hope you enjoyed watching this video.